Hello and welcome to the Unit 6 Section 3 video on similar right triangles. So we're going to start off by identifying similar right triangles. In a right triangle, an altitude is drawn from the vertex of the right angle to the hypotenuse, and that forms two right triangles. So you're going to notice this is similar to something that you saw back in Section 1, that second proof of the Pythagorean theorem. So the altitude to the hypotenuse of a right triangle forms two triangles that are similar to each other and to the original outer triangle. So here we have our big triangle, ABC, is similar to our medium-sized triangle, ACD, which is also similar to our smallest triangle, CBD. So we're going to start by writing a similarity statement comparing the three triangles. So that's what we're going to do here in example 1. So let's start off by drawing three similar right triangles. One that's large, one that's medium size, and one that is small. So here are my three similar right triangles, okay? And all three of these are right triangles. So we have right triangle here, we have a right triangle here, and we have a right triangle here. So let's label it. So the first one's easy. It's oriented the same way as our outer one, so this is going to be T here, R here, and S here. Now, let's look at the middle size one. The easy one to pick out is where our 90-degree angle is. That's P, okay? Now, our long leg takes us to T, and our short leg takes us to S. And for the smallest one, again, our 90-degree angle is at P. Our long leg takes us to S, and our short leg takes us to R. So now we can write our similarity statement by the right triangle altitude theorem that RST is similar to SPT, which is similar to RPS. Because remember, when we write similarity statements, the vertices have to be in the same orientation. All right, now let's talk about finding geometric means. Consider the proportion a over x equals x over b. Okay? In this case, the means of the proportion are the same number, and that number is the geometric mean of the extremes. The geometric mean of two positive numbers is the positive square root of their product. So in other words, if we multiply the two numbers and then take the square root of them, we're going to get our geometric mean. So you can do x equals the square root of AB, or you can do x squared equals AB. They're both the same thing. So if we want to find the geometric mean of 4 and 9, you're going to do x squared equals 4 times 9. So x squared equals 36. So therefore x equals 6. So our geometric mean of 4 and 9 is 6. For b, let's do it the other way. Let's do x equals the square root of AB. So you can see it works the same way here. Well, x here is the square root of a times b, which is 6 times 15. 6 times 15 is 90. And the square root of 90, if we get it in the simplest radical form, is 3 square root of 10. Now let's use the geometric mean in right triangles and use it to find side lengths in right triangles. So you can use the right triangle altitude theorem to write proportions comparing the side lengths of the triangles formed by the altitude to the hypotenuse of a right triangle. So we've talked about these three triangles being similar. We showed that in example 1. Well, if we split up that large triangle to create these two similar triangles, we can create proportions. B over A is equal to y over h, which is also equal to h over x. We're comparing our legs here. If we compare our hypotenuse to our short leg, we have c over a is equal to b over h, which is equal to a over x. And then finally, we can do the hypotenuse to the long leg. C over b is equal to b over y, which is equal to a over h. We end up getting a couple of corollaries out of this, where we find that our altitude h standing for height here because a is already used, h squared is equal to x times y. So if you know these two lengths from our similar triangles, then you can find h by taking the geometric mean. Similarly, you can do a squared equals x times c. So a is x times c. B squared is y times c. So let's do some examples of these. Starting with example 3. Let's find x, y, and z. In fact, I'm going to leave this up just so that we can use it. So let's start with x. We know that x squared here is going to be these two values here, 2 times 10. So x squared equals 20, and you take the square root of each side, you get the square root of 20, and we simplify that, and you get to square root of 5. A squared in this figure is our short leg. Our short leg is z. So we're going to do z squared equals 2 times this entire length. This entire length is 12. So, in fact, let's do y first. Let's go in order here. Y is here. The corresponding section of the triangle is 10, and the whole length there is 12. So we've got 10 times 12. So y squared equals 120. Take the square root of each side, you get the square root of 120, and when we simplify that into simplest radical form, you get to square root of 30. Now let's do z squared. Same sort of process. We're going to take 2 here and multiply it by 12. Z squared equals 24. And so z is the square root of 24. And if we simplify that, that's 2 square root of 6. And finally, let's do an application. So very much like we did in the last unit, we are going to estimate the height of something using special right triangles. So to estimate the height of Big Tex at the State Fair of Texas, Michael steps away from the statue until his line of sight to the top of the statue and his line of sight to the bottom of the statue form a 90-degree angle. His eyes are 5 feet above the ground. That is easy to measure. And he is standing 15 feet 3 inches from Big Tex. Again, something that is easy to measure. How tall is Big Tex to the nearest foot? That is something that is not easy to measure. But everything is drawn out for you here. So let's let x be the height of Big Tex above eye level. Okay, so we're going to let this portion here be x. So we have our h. We're going to use h squared equals x times y. We know our h squared is 15 feet 3 inches, which that's 15.25 feet. So we're going to go ahead and convert that to just feet. 15.25 feet equals x times y. Y is 5, so we got 5y here. Or I should say 5x, because y is 5. All right, you do that math, do this, square this, and then divide it by 5, and you're going to get that x is 46.5125, which is, to the nearest foot, approximately 47. So again, word problem, let's do a word answer. So we can say Big Tex is about 47 plus 5, because remember, we just found the value of x. We did not find the entire height, so we have to add that 5 extra feet back to it, or 52 feet tall. So don't forget to do that last little bit there. Because we found x here, we had to add 5 to it to find the height of the entire thing. All right, so that finishes off this section, another short section for you. In the next section, we're going to wrap up the unit by getting into a little introduction to trigonometry, which has everything to do with right triangles. Come into trigonometry with an open mind, because it is not as hard as you think it is. That's coming up in the next video.